Welcome, everybody. Let's go ahead and get started. So today's webinar is being recorded. It will be uploaded to our YouTube channel, which you can find by either searching Spear on YouTube, or you can go to our website at eepartnership.org. And under our news section, you'll find our resources page. Once you're on our resources page, you'll find the link in the upper right corner to our YouTube channel. As always, within 72 hours of this presentation, you will receive a course evaluation email from Kathy Lawrence. Please complete the survey and send it back to her to receive your course completion certificate that it will contain your course ID number that you'll need to use when reporting your CEUs to ICC. Please keep in mind that to get your CEUs and receive your course completion certificate, you must be present during the live version of this webinar, and you must be present for at least 3/4 of the presentation. Lastly, the chat and Q&A feature is open. I will be monitoring those during the webinar. If you have any technical difficulties or any questions you'd like to ask, please post that in either the chat or the Q&A, and we'll try to get to those questions as they come up. So let's get started. For the first time, if you're here for the first time, who is Spear and what can Spear do? We are a nonprofit organization. We're what's called a RIO, one of 6. We're nonprofit member-based. And what we do is we focus on providing training, webinars, in-person and field training, as well as IECC test prep training for anyone looking to get certified. The price is always right. It's free. I can help with technical assistance and questions regarding the energy code, ASHRAE 90.1, can help with questions from plan reviewers to building officials to third-party inspectors. I'm happy to help in any way that I can. We also have assisted several cities in their adoption of the 2021 and how to navigate through all the additional amendments that are being used out there that are lessening the impact for your builder community. My contact information will be at the end of this presentation, so please feel free to reach out to me at any time. Please feel free to share my information as well if I can help navigate the code for anyone or anybody that has any questions that may be having a permit review or going through questions in building. So identifying leakage points. So I just put a few on here that we can go through, but identifying the boundary. When I start training the energy inspectors, it's always teaching them where does it start and where does it stop? And then start with the outside air barrier first. What material is being used? How well is it being sealed? Are they using the manufacturer's instructions to do that? How well is it done? And then know your scope of work. Is it 1 story or is it 2? When you walk into the house, if it's a 2-story, then now you have to pay closer attention to other areas like band joists, floors over ambient, floors over garage. Always look for dollars, not pennies. In other words, identify the bigger holes first. Pinholes and T-ply is one thing, but that's chasing the pennies, not the dollars. Follow the path of air movement. So where can it go once it gets in the cavity? Follow the wiring. Find out where it goes. And find out where that pathway can lead to and how it can come out into the building. Also, understand what's going to make air move. It's always based on temperature differences, pressure differences, and stack effect. That's what can move air back and forth. Is the air sealing method good enough? Is the entire hole sealed? In other words, we'll see more of this later on in today's presentation, but did they just poly seal the front of it and not the back? And then lastly, it's not always about air leaking into the building, but also about maintaining the R value of the insulation. We always talk about this in the webinars, but if insulation is not fully enclosed on all 6 sides and it's exposed to any air movement at all, or even a different temperature of air, like an attic, air will move through the insulation, effectively lowering its R value. So that's one reason why it has to be sealed from the backside in the attic. But as we always go through, what does the code say? There's 3 different things I put on here. It's out of the R402 sections, but it defines the air leakage. So the building thermal envelope shall be constructed to limit air. Also, building thermal envelope, the sealing methods between dissimilar materials shall allow for a differential expansion and contraction. So between T-ply and solid pieces of wood, they expand and contract at different rates. And then installation, we'll look at that table in a minute, but it's the components of the building thermal envelope shall be installed in accordance with the manufacturer's instructions. So we've seen this before. This is the table we've always talked about. It lists each component to the left. The air barrier criteria is in the middle, and then insulation criteria on the right. All of these items, if present, should be verified during all stages of construction. So is it the air barrier on the outside during pre-construction and pre-installation, and you're doing an air sealing inspection, Or is it the ceiling sheetrock at close to final? How is that stuff being sealed? It lists the criteria here on how it needs to be sealed. Now it needs to be verified as you go through the inspections. So this is the first of our videos that we'll watch. I'll pause it a few times to discuss what we're looking at. This, we're just starting on the outside first, looking at the flashing around the windows. Is it flashed properly? Of course, you'll see air sealing on the inside. What I'm really looking at here is looking at what air barrier are they using. Here they're using T-ply. So on the T-ply, are they lapping the seams? Are they butting the seams together? Are they taping the seams? Are they taping on the exterior corners? Right here, we're looking at that. Are they taping on the interior corners? Are all the penetrations sealed as well? They're using zip system taping here. That's a great choice. But the corners, interior corners are being sealed. They actually put tape on this drainage plane here on the outside. I'm not sure why they did that, but I checked below that and they still are sealing it really well at the bottom of that T-ply. Plus they're sealing it also from the inside. So just walking around here, we could walk around the whole building, but that would take too long. Just evidence of what are they doing. There's a second floor above. It's actually just a loft area that's over that front door. So just looking at the T-ply, making sure the nailing pattern's followed. Are they following manufacturer's instructions to do the nailing pattern? Are the nails too far apart? If they're more than 3 to 6 inches apart, that's not going to be per manufacturer specs. It's going to allow too much air leakage into the building. However, as you can see here, what they did was they added more polyseal at all the seams and all the junctions between T-ply and wood structures. They actually have put it between the framing. There's a top plate gasket you see at the top that's going around all the separations, but from conditioned to unconditioned. Verifying the front door has polyseal around it. Most of that is too much. They'll scrape it out when they start hanging sheetrock. I usually try to do the house or start the building in a either counterclockwise or clockwise motion. I stay in one room and work clockwise or counterclockwise, looking at all the top plates. I'm not really overly concerned with down towards the bottom at the bottom plate because they're all interior walls. I'm concerned with where it meets the exterior or the unconditioned attic. Making sure all the T-ply is sealed on all the seams. Stepping into the next room. Looking at the framing members here. Looking at how the windows are framed. I always have a bad habit of making sure that the windows are actually insulated through the headers. So these are, I don't know if this house is going for Energy Star, but that's what you would see. Now it's also code required. Checking the air leakage rate on the window sticker. It meets code. It's 0.30 or less. So it meets code. I also have a bad habit of looking in the corner and just making sure they're doing advanced framing. You can get insulation back there. But those corners are a great place that people overlook that with the polygun. They don't actually seal in those actual corners. So just making sure all that's done. They put a bead of poly against the base plate all the way around. Again, just verifying the top plate, checking that gasket, making sure it's done. They've used a full 3.5, 4-inch gasket at the top. So they've done a really good job of making sure that top plate is sealed. But as you see in the room next to us, it's a ceiling that's been lowered. So there's a different plane there. We'll talk about how to separate that in just a minute when we go into another room. But looking at that now, checking into another room, walking into this room. This house had a lot of vaults in it. This is directly against the decking, but a lot of vaults that you see here that drops down. The one thing I pay close attention to is these blocks on the corner. So a lot of times those are top plates that have to be created because they've lowered the ceiling at that point. They have to recreate a top plate. And so they have to put the blockings there. Those are missed a lot. So again, checking that corner there, making sure the T-ply on the back of that vault, because that vault, even though what we're looking at is not in conditioned space above it, it is conditioned space on the other side, so it must be sealed. Again, just verifying the corners and make sure they poly seal back in those corners. They're using advanced framing, but let's make sure it's poly sealed in the corner. Just checking the top of those walls, making sure where it drops down, it's actually blocked at that point. Verifying all the seams. Again, I'll also verify this header, make sure it's insulated, and it is. Just anywhere in those headers need to have a thermal break in them or a thermal bridge breaking material that's there. They just used a 1/2-inch foam board. Checking that, making sure it's all sealed. Checking those blocks as well. Looking at where that what was I checking was there was making sure, see where that gasket was actually meeting that top plate that was created. Wanted to point this out. A lot of builders don't make sure this is done. Whoever's doing the air sealing package on this builder is actually knowing what they're doing. They've been told how to do this correctly. But putting a gasket below a beam, that's a perfect detail to look at, because what you've got is a higher ceiling, a lower ceiling. Air will actually travel through here and into the adjacent walls if it's not done. So putting those gaskets below those beams are key. We learned that the hard way by verifying it with an IR camera, that air does make it past there, regardless of what people think that it's air sealed. If the sheetrock's pushed tightly against it, it still leaks. Here's a plumbing wall in the back of a bathroom. It actually has the double wall that's built there for the plumbing to be put in. This is just a 2x4 and a 2x6 butted together, but they've poly sealed that seam. Perfect way to do that. And later on in the presentation, you'll see one that's left wide open. A lot of times we'll find those left wide open. Polysealing all the piping, the water piping. Looking at that. Looking at this gasket, though, again, going back to the details, they know what they're doing. They're actually pushing these corners tight in there with the gasket so that when the sheetrocker comes in, it's not bowed out and it doesn't get torn or ripped at the corner, because that will allow air to come down through that U channel or C channel behind that T wall, and it'll find its way to any electrical box on that wall. So pathways are always found in these areas, making sure that it's also sealed here. Now we've got a height change here, but what I'm doing is verifying where is the blocking and does it meet that gasket? Does the gasket have something to be pushed against to actually add actually to be as a gasket, act as a gasket? But at that point, when I was looking at, we'll see another one a little bit later, but it wasn't acting as a backing to that. The block was too far up in the wall. So moving to the next room, verifying this. This is a media room. So they've got a lot of boxes on the wall, a lot of open boxes, just verifying, are they T-ply, or is the T-ply meeting at the bottom? They're poly sealing up against that T-ply. They've got a bead of poly there. I did verify there was a gasket underneath the base plate. That's also for a moisture wicking, a barrier there, but it also acts as an air gap sealer. So looking at the wall, just looking at yes, they use advanced framing. Yes, they're using a 2-stud corner. Can't really see that they've poly sealed back there. I put my hand back there and I could tell it was poly sealed in that corner. But looking at this, a lot of times there's a bump ceiling here. They've added a gasket at the top. That's not really necessary. Yes, it's adjacent to an unconditioned attic, but if you look at it, there's really not a pathway to get air down through the sheetrock. It'll meet another gasket at the top plate here. That to me is just kind of an overkill. I like to see it. It's attention to detail, but it's not necessarily needed at that bump ceiling. Open boxes for that Smurf tube that's there, but all the other boxes have been poly sealed from the back. That looks great. There's a big T-wall here behind that plumbing wall that we're looking at. I actually take a closer look at that. That's a gap up into that attic. It's not poly sealed there. This house has not been inspected yet by a third party, so hopefully they'll catch something like that. Electrical boxes on the wall, the sconce boxes on the wall, making sure they're air sealed as well. But then you go back here to these speaker boxes and there's no poly seal on those speaker boxes. They've poly sealed the top of the wall. Again, they've got some really good attention to detail looking at the gasket. This house, again, had a lot of vaults in it, a lot of vaults. It's a really good architectural feature, but it adds to the complexity of how you're going to air seal the house. Looking at the blocks, again, we can see here, I'll pause for a minute. This gasket is just free flowing. It's not really, there's nothing backing this. When the sheetrock goes up, it can just be moved around because there's nothing behind it because the blocks are too far up into that cavity. Do I expect them to fix it? No. Is it something you could speak to the builder about and say, hey, these blocks need to be placed somewhere else? Absolutely. I don't know what came first, the blocks or the vault, the pull down vaults. Probably more than likely the blocks came first and the vaults came down and it met it. Same thing's happening here. The front one that we're on the standing on my side doesn't meet that gasket. The other one, there's kind of a lip there where the gasket's been pushed up. You can see it's floating right here. There's a whole gasket that I can see all the way down the wall. So did it meet the intent? Yeah, they put a ceiling there, a gasket there, but it's not fully air sealing the wall because it doesn't have anything behind it. So drop ceiling, they've taken care of those little drop ceilings there around the fireplace chase. They've done a really good job with that. However, there's a hole right to the attic there. Gets a little blurry, sorry, but right there where that framing comes down, it goes all the way up into the attic, needs to be poly sealed. There's a lot of electrical boxes on that wall that has that air that will actually come down through that area. Checking the stairs, they've overkilled the poly seal around that. That's great though. They'll shave that down when they go to sheetrock it. Making sure the pull down stairs are actually an R10 insulated. Those doors do come with weather stripping already, so I did verify that weather stripping was on that door. Again, checking the gasket, mostly being concerned with all around the top. Also, what I'm concerned with are these ceiling joists from the shorter ceiling, making sure, are they poly sealing around all of those? A lot of times they leave those done, or they'll just do the sides and leave the top open. Is there a way that air can get down? Yeah, there's not another gasket here, and if there's a box below it, it will pull air from those ceiling joists that are poking through the T-ply. Checking those corners, floating gaskets again. I mean, it's there. It meets the intent. It's not really doing the best job. That could just be a discussion with the guys doing it. He just doesn't fully understand that there needs to be a back. Same thing with this up here. I'll take a closer look at that. There's blocking up in there, but there's not anything behind it. This is a very big plumbing wall there. They've put the way the studs have been put in there, they actually have enough room for insulation. Making sure we're following the piping, the line set that comes through, all of that's been poly sealed. We've got a bathtub on an exterior wall. Again, we have the same thing here where you have a plumbing wall that's furred out. They've actually sealed that joint in between. So they did a good job with that. That's really a big stud pack here. There's no insulation in that corner. Not much you can do about it, but it's just, there's no way to insulate that corner. Insulation's been pre-dropped behind the tub. They've pre-dropped T-ply behind the tub, so that meets the requirement of internal air barrier, insulation, and external air barrier. So that is a great way to do it. They've planned ahead and did this correctly. I'll actually just take a look underneath the tub. It is nailed there. They didn't poly seal much past here. That's fine. And at least they've got an air barrier that extends all the way to the top. They met the intent. They didn't fully air seal it. Looks like they did it, the poly sealed afterwards. They should have done it before the tub was dropped. Scanning around the top plate again, looking for any breaks in the top plates. Everything seems to be adhered to right. Looking at the bath fan, making sure the bath fan actually moves to the outside. It's not crushed or kinked. Following that top plate gasket. Checking that plumbing pipe or that black iron pipe, the gas line, to make sure it's polyed all the way around the pipe. Looking at the blocking that's coming down from there. Another little drop seal, and this is the other side of that fireplace chase, so we'll take a closer look at that in a second. A lot of AV wires through there, a lot of poly seals. Again, floating gasket, no blocks there. Does it meet the intent? Sure. Top of the fireplace chase is being capped and sealed. We'll walk to the front of it here in a second and get to the front of that so you can see a better shot of it. I'm gonna have to step through the wall. But now you can see the other side of that drop down. It's actually, there's a gasket there for the can light. That's perfect. It exists now. Will it stay there until sheetrock? We hope. That's why it should be verified again at final. But checking the top of these walls, looking at this extremely long knee wall, making sure all the blocking exists, all the air sealing exists, all the way down the side of that wall. The blocking continues all the way down. It's a poly sealed against the T-ply. The fur downs or drop downs here have gaskets. They didn't put a gasket in the front over this beam here. Not really huge, a big deal, because there's not a lot of air chases through that, but that's one thing that they could have done. Checking the other side of the cap for that fireplace. You see they poly sealed around the squared around transition. They also put fire caulking around the flue pipe, which sometimes is told that they can't do that because the fire marshal, I'm not sure why, but Double wall here, making sure they polyed the seam all the way down, following that gasket all the way down in this great room. Stepping into the front area here, probably an office area, another fur down or bump ceiling there with another gasket. All the seams are sealed. They've sealed against the T-ply here. Now this is adjacent to the garage wall. So following the poly seal up the corners, making sure that's done correctly. Again, you got the bump ceiling that's here. That's not really necessary at the very, very top, but this second one actually is what's needed. Checking to make sure is the blocking there? Is it blocked all the way around? Here they had to create top plates against those windows. That exterior wall doesn't really match like it should. I've got like that bump in the middle with that bump ceiling. I'll look at it in a minute a little further, but it kind of questioned on how they were going to insulate that. They're probably going to tear the gasket down to insulate it. Here we go looking at it now. The blocks are below it. There's no blocks behind it. All of this needs to be insulated, which means they're going to rip that gasket out to insulate it. So not a huge deal, but it's one of those things, cart before the horse, chicken before the egg. What do you do? Looking at the gasket across the top plates again, just verifying every single room, clockwise, counterclockwise, however, just have a pattern, know what you're doing with that. With this wall here that we're looking at, I like to point out that anytime you see shadows, I always like to look up into that shadow and make sure, is it blocked at the top? And if it is it also air sealed with poly? So when you see shadows at the top of the wall, there's a dead space or a pocket at the top that needs to make sure there's a block above it. So following the gasket, other end of the great room, got the blocking all the way across the top. A lot of times here, this feature at the top, they'll leave that open and it has a space to the attic. This one, they actually sealed it really well. Following the blockings as well. This kind of jumped out at me. It's a big kitchen exhaust. So I know it doesn't anything to do with air sealing, but having a pipe this big means you're going to have makeup air. So we need to find the makeup air, and I kind of look at it a little bit later. I didn't see anything in this room that showed me to be a makeup air. Looking at this gasket, just checking all the way down the wall, everything's sealed, all the seams are sealed, all the poly seal around the wall, the windows, poly sealing on the electrical boxes. And so they overkill with the poly seal, but they didn't seal the bottom of it. Just way too much poly on the top. Could it be done better? Sure. Did it meet the intent? Sure. I mean, it fell out because it was too much. They really need to try to hit just those little spaces that are needed to be poly sealed, not just put a big glob at the back. Again, another room with another vault. It's that way a lot in this house. Double wall again at the entrance, has a spacing there that they've actually sealed. Looking at this corner, it's a dead space corner. It doesn't have any room for insulation. There's no way to insulate it. Probably done because of the support beam that's coming down on top of that corner. Not much you can do about it. Same thing on this side. There's not any advanced framing happening in there. You can't seal you can't insulate that corner, but they did poly seal the corner. Now looking at this top plate, and then something caught my eye. I looked out over the patio, and there's a really big vent opening that's there. That's going to bring it up a little bit later, but that's part of the exhaust or the makeup air. Then it says gas barbecue on the other side. Not a really good idea to put those in the same area. It's best that they did separate it. It's a big patio, but making sure to poly seal across the window door itself, checking the top of it. Sometimes these doors are really tall. It's hard to see without a ladder, but luckily for the camera, I've got a stick I can look up there. But you got poly seal, gasket. So you got a slip gasket underneath the base plate. I found multiple evidence, the fact that they did do that, so that I didn't have to go tear up everything and look for it. But continue around the house. Spacing at the top is sealed, done really well. Checking that, looking at this is a shear wall, so they've put red T-ply here for the shear wall, and they've actually put the gasket and done it really well. Evidence of duct testing, they've got a hole cut in it. I'd like to see that hole cut bigger if you're going to do testing, but poly seal, a lot of it here just to fill in a gap. I guess that's okay. We'll look at it more in just a second, but checking this is utility room, checking all the plumbing vents, the plumbing pipes, Checking the bath fans, making sure there's no kink or crushing there. I know it doesn't have anything to do with air sealing, but at this stage, I just have a habit of always checking these out. They did it right. They didn't just cram them in a one size hole. They actually have a T-splitter there. Checking that back door, making sure it's air sealed across the top, air sealed down the sides. Again, not a energy corner here that's dead spaced in the corner. Not sure if they could have done that or not, but should have been able to do something. Looking at this part of it again, it's poly sealed really well there. Ball in the top plate gasket. Not a lot of mistakes or bad areas in this house. This house was done really, really well. That again, that air sealing company knows what they're doing. Checking the block and the framers know what they're doing as well. Framers as well. But there's an after effect here. Also, we've got a plumbing penetration that's either had to have some repairs or had to be moved. So they had to tear this out. You see the poly seal was already there. They actually tore this out. Most trades won't go and tell someone, hey, I need to have this sealed. Luckily, it hasn't been inspected yet, which means that they're going to probably catch that during the inspection and spray paint that to be fixed. But checking around the HVAC return, making sure that's been poly sealed. A lot of times they'll leave the bottom one because you can't see it from the ground. They assume nobody's going to see it. Making sure the supply boots are actually sealed. Another plumbing penetration that had to be moved. My guess is they had to do something with either raising that ceiling or changing ceiling heights. The plumbing was in the wrong way. Making sure it's blocked all the way at the top of that vault, and it was. Just going back through and looking at that part of it. This is kind of a uh, little niche here for a window. This is a lot of times these side walls are really bad about having air leakage through here because they don't really, that of course is the exterior, not an attic. So it's really done very well, but they put gaskets across all the way across. Could they have done it on this block? Probably, but there's not really a pathway from there all the way down. This is one thing that caught my eye though. This has been air sealed with a gasket and it's actually got red T-ply underneath it, which is fine. It's now sealed, but it's not insulated. So all of this is going to have to come down again to get insulated and put back up. Not sure why they did it. It's going to be sheetrocked anyways. I guess I don't, again, I don't know. I mean, insulation usually holds up in its place. Even if it's upside down, you could usually put insulation here and have it hold up, but they've nailed it up. All of this I verified, couldn't really do that on camera with one hand, but I did verify that there was no insulation inside of that. So which means it has to be taken down. It's going to have to be insulated. But just verifying those little push out windows are done correctly, verifying the windows poly sealed. This seats are always a problem. They usually have gaps in them that aren't sealed. This one is done really well. OSB capped at the bottom, poly sealed on all the seams, done really well. Left the corners where you can insulate more of that window. So still a question mark. I'm not sure. There was a evidence. I guess they did do an inspection before this. They actually spray painted and put block and seal, but blocking and sealing is not just putting T-ply over something and covering up where you can put insulation. Still checking out the gaskets. Keep following this all the way around, looking for any dead space. This is a closet. They've done some really good job of just using every square foot that they can. There was not a lot of dead spaces in this plan, meaning it's not just a chase that's not open to the conditioned floor. Looking at the backside of this vault over the great room or kitchen area, there's the vent pipe for the kitchen exhaust. Subflooring for the upstairs attic. Another bump ceiling in another room. Looking at that gasket. There's a header here that I don't know if that's the right size for the load. That's awfully big, but I'm not an architect or an engineer or designer, so I'm not really sure. Checking the gaskets, making sure everything's poly sealed, looking at the windows. Here's the bathroom, the master tub. They've pre-batted and pre-T-plied and pre-air sealed underneath there. This should be done. It still boggles me how I see a lot of builders still not doing that and not having it in their staging for planning. It's an afterthought, and somebody's got to get underneath that tub and crawl underneath it to fix it. That's just a lot more difficulty than it has to be. Polysealing all the lights in the ceiling. Again, following the gasket, looking for dead spaces, looking for misalignments of the top plates. Now we're at the garage wall. So Smurf tube there for the low volt wiring. That's the right size header. If in my opinion, it's actually sized correctly. The baffles go all the way up to where it'll extend beyond the insulation levels. They're in every cavity. So they're building to a 21 standard, but in the city that they're in, they're only at the, I believe it was the 2015. Looking at the garage wall, is it poly sealed? They have a poly seal beam here. Every seam and seal is polyed around the piping. Water valve boxes. I understand it's in the same cavity with that, but they really need to be framing around it and closing that off because that's a direct opening to the cavity when it's facing the garage. And you know it's not going to have a gasketed door, so it needs to be framed around it. So polysil there, just following that gasket. Polysil around the door. The door is weather stripped. Polysil on the top, down the sides. There is open electrical boxes on the wall. They've polysealed a lot of it. Polysealed the corners, which is a really good detail. A lot of them are missed for that. A lot of them you see that is not doing that correctly. Polysealing any T-wall intersections on the garage wall. Another great detail to see. That's a T-wall coming in. So they're actually polysealing all of that. They did a really good job with that. This builder, again, goes over and above with separating the garage intently. That's why I'm assuming this may be Energy Star, but they're gasketing around all of the exterior garage wall. Here's the electrical box pushed out to the outside, but checking the gasketing all the way across the bottom. They're picture framing that entire garage wall, making sure there's no points of air leakage into those walls. So a lot of polysil in the back. Some of that will be scraped out. Again, if you see a shadow on the wall, look up. Check that shadow. It's blocked at the top. It's polysiled really well. Attention to detail here. Again, they've done a really good job with that. So now I'll just go in the attic real quick and just look at a couple of things. I won't do this on all the houses that we look at today, but again, looking at the garage wall, making sure it's picture framed. I do go up to this base plate and make sure, does it still have a gasket there? We saw evidence of that on another wall, but just to verify specifically, is it on the garage wall? And there is evidence of a gasket there. So that's great. That is one requirement that Energy Star does require. And if that's not done, it is subject to failing your certificate or your certification of the house. It's just a call out on the checklist that must be verified. The rest of the house is usually done because it's a moisture barrier from the top, from the base plate. But most framers don't think that's an exterior wall in the garage. However, from an energy standpoint, that is an exterior wall. Tankless water heater is going to go up inside the attic. Here's the flue pipe around it. They could have done a little bit better job at running it through the wall or through the ceiling. Just checking the trough where they've got it there. There's not a lot that I'm going to be looking for other than I needed to find out how are they going to do the makeup air for the kitchen. And I'm always curious to find out what kind of ventilation they're going to use for mechanical ventilation. This damper drew my attention. It's a 10-inch duct. And it's a Honeywell damper, open and closed. So that is what I'm assuming, and it is. That is the kitchen makeup air as they're dropping it right into the return. And they've got a April Air mechanical ventilation box next to that. Seeing this always kind of blows me away. This is not, should not be allowed for code testing. But what they're doing is this door has a gasket on it. The gasket needs to be effective. If the gasket isn't effective, it needs to be fixed by the mechanical contractor. However, in order to pass the duct test, a lot of times people will tape these doors shut in order to pass the duct test. In my opinion, it really should not be allowed. I understand if you're looking for a few CF films, but that's not going to stay that way. The first time a homeowner gets the filter out, they're not going to retape it. Just checking that, and since I only saw one inlet on the over the patio, I wanted just to check where is this going. So I have a 6-inch fresh air duct coming in, or mechanical ventilation. We call it fresh air. And it actually goes right alongside that and juts into the side of that same 10-inch duct that goes to the outside for the makeup air. So I guess that's one way to do it. I don't know that that's the right way to do it. Probably by code, it's probably meeting the intent. The intent of putting makeup air in is to balance the house in the area instead of having the area that you're in become depressurized. You want it to balance by pulling in the same amount of air that it's pulling out. I guess dumping it in the return does that. I'm not sure if it will balance it in the same area though. Just looking at this, making sure it says R6. So if they're going Energy Star, that's acceptable still, even in 2021 code areas. But if they're going 2021 code, that's no longer acceptable because that's not an R8. So either A, it is not doing 21 in this city, and then B, it's probably either going for Energy Star for that. Just looking at the hanging of the ductwork, again, I know it's not air sealing measures that we're looking at. Just verifying how they're hung, looking at how it's air sealed in the back of this return on that wall. And then also just getting a quick snapshot of, well, there's the bath fans we're looking at. That's gonna be really done well. They're probably gonna pass those bath fans with testing. If they're doing Energy Star, they have to hit 50 CFM. And then getting a shot of just, well, there's a boot that's insulated, and then getting a shot of what it looks like from the top when you're looking at the gasket. So this is what the gasket effectively does, is just picture the fact that you've got sheetrock against that. It stops air moving at all these joints to go down that wall. This is an effective gasket being done correctly and being installed correctly, in my opinion. So that's the way it's done. So good job with that. Looking at the back of this wall, looking for openings in the T-ply. It looked done really well in the front. Checking the nailing pattern. It's a little bit more spaced out. It's not following manufacturer specs. Could it leak air through there? Probably so when you run a blower door, but not on a daily basis, probably for pressure differentials. They just kind of don't really nail T-ply on the interior like they do on the exterior because it's not a drainage plane at that point. It's just an air barrier. And then this last thing I'll do with this, just verify, is there an actual fitting in there? And there was. They didn't just cut and splice it. We've talked about that before on previous inspections, is just cutting and splicing. Last thing I did do here was check for mastic. I didn't really feel a lot of mastic there. I think it's probably less than what it should have been. Should have been a little more mastic that was there. As you can see, I don't see any evidence on the outside of it. They probably did it under the mylar of the duct, but probably not really to what it should be. So we'll move on to the next one. Here's another house. I don't walk the entire house with this, so we'll just take a look at it real quick. Again, starting with the outside of this, checking the outside air barrier. Is it taped correctly? Are they butting the seams? Are they overlapping the seams? Are they taping? Are they taping the corner? There's flashing around the windows. Even though that's a flashing detail for windows, it's also an air stop. Flashing is not done over the door, so hopefully somebody will catch that and call that out. So looking at that being done, taping through that. This house is a little bit different architecturally, same builder. It's just a lot more chopped up and more decorative stuff that causes it to be a little bit more difficult on air sealing. Having some architectural features, you see floating gaskets. They're just, that gasket's basically ineffective. It's going to be probably torn down when they're trying to put sheetrock up. But as you see, just a gasket all the way around. This room was just a big poly mess everywhere. Can't complain when it's using for air sealing, but it's just a lot of poly seal on all the seams, on all the corners, at the ceiling joists where they're coming through the T-ply, all the way around in the corners again, at all the posts and the ceiling joists that come through here, all the tears and the framing members and roof purlings and all that drops through have been sealed. For some reason, this plan, they didn't do any insulated headers. So maybe this one was following code only and not doing Energy Star. Pet peeve of mine, just decided to zoom in on that and say, hey, there's OSB. There's not any insulation there. This one had been inspected already, so I'll just show you. He spray painted down here, block and seal, BS walls, block and seal walls. So at the top of each of this closet on the wall, they actually had T-ply. They've cut it and put it in place where it said it needed to be blocked, but nobody's poly sealed it. I can still see up into the attic. All the seams around here, I can still see up into the attic. But as you can see, just a lower in ceiling height causes that to now need to be blocked. That's a dead space here that's got OSB at the top and sealed. That's done really well. Look at it from a different angle. They've polysealed all of that. Done a really good job with that. And then you've got, this is just a closet we're looking at from the entryway or from the hallway. And then they've done a little spray here, block and seal wall. This is the fireplace niche that goes all the way to the other side of the house. So we're just going to verify, is it blocked at the top? And then there's two spaces on each side, two niches on each side. They had to block around it. They used just wood, polysealed all the seams, but they left this open at the top. So they've had to put T-ply there. It's blocked all the way down there. We'll look at it from the other side in just a minute. It's blocked there at the flue pipe. I can see evidence of polyseal around the transition. They've done a really good job with that. Block and seal wall here. It's a double wall that's at the top. So just making sure they're blocking all of that. They've asked them to block and seal the top with T-ply. They did, but they didn't polyseal it yet. They've put blocks. This is an additional top plate that they created below that, which is needed for stopping air from the attic. It can't be left open, so they went ahead and blocked that from that part of it. And then here's on the other side, looking at it from the hallway, walking through. It's just an architectural feature in here. I forget what they call them, but there's a double wall in between. They've put the seam, sealed seam there. They've got the gasket there, but I did have a question about, this is the only gap. This is a service decking walkway that goes to the HVAC unit on the other side of the house. But that walkway is already nailed down. This is the only opening for them to be able to apply insulation. I don't know if that's big enough for the installer to know that he's correctly putting enough insulation in those ceilings. I'm not sure. Blocking at the top of this, little architectural curvature of the wall. As you see, spray paint here, they missed blocking below that wall. The blocks have been added, but they left it in the corner. But of course, they haven't polysealed it yet. They'll probably polyseal those corners. But they need to polyseal all those seams. There's a double wall here where they've actually done that. This is the adjacent garage wall. So this is a lot of blocking and spacing. Gaskets there. You can see gaskets here. Again, gasket at the top of this bump ceiling. Not truly necessary. If it wasn't there, I wouldn't call it out. But they did it, so you can't fault them for trying to go over and above. And then this next one that we have here. So now we're over in the master bathroom area. There's a lot of chop up areas, a lot of dead spaces, a lot of gaps where airs can get through. This is done really well. The top of this triangle piece is done with some polyseal. Polyseal around all the low volt wiring, security wires, the Smurf tubes. Polyseal in the electrical boxes. Gasket's kind of falling down, but that's all right. But hey, they put it on the bottom of that beam. Not a lot of places do that. So gasket across the back of this. We'll look at those beams again in just a second. Polyseal in the back of that and the blocking of that. Another odd little niche there, making sure that's blocked in the back, making sure it's OSB'd and air sealed at the top. They've done a really good job of that. That's the shower area that's there. Here's another feature where they actually got this called out. So they've made barrel ceilings over the master bath and barrel ceilings over the master bedroom. They had to block all of these. I know it's odd for odd angles and odd cuts. And they can just fill all the gaps with polyseal, but it's just a horrible, well, I say it's not horrible. It's a nice little area that they've done, but it makes it very difficult to air seal that area. But is there pathways down this wall and into whatever's on the side of this? Maybe, maybe not. But as we said in the very beginning, it's not all about air getting into the home to affect the blower door. It's also about air getting into the insulation to lower its R value. So that's what we're mostly concerned with in those areas. You're more concerned with diminishing R value, not failing of a blower door. Here's the gasket on the bottom of that beam. Follow it all the way down to the outside. Again, another outside wall with that barrel ceiling or half barrel needs to be blocked. They've done that. Another little kind of odd chopped up dead spaces. They've used decking boards here or just some 2x4 scraps, 2x6 scraps. Polysealed all the seams. These were done right, but the next one that I'll show you in a second is not done correctly. Well, it's done correctly, but it left a lot of gaps. This one here, so they've actually been called out to block and seal. Actually, I don't think this one was caught on the inspection, but left open at the top, gaps all the way around. All the measurements that they did here to cut this stuff correctly. The T-ply has been dropped in, but not poly sealed. Gap still left at the top of this. And we look at it and say, well, is that really detrimental? Well, there's electrical wire coming down over here. In a minute, we'll count all the boxes to see where would all this air go if it made it into the cavity. Once it made it into the cavity, not if. It's when it makes it into the cavity, how many boxes will it exit? So there's one right there. And it's going through all the vertical and horizontal holes in this wall. So there's one box. There's two boxes. 3, 4, 5. There's 5 boxes on just this little short wall here. So that all of that air is going to make it through every single one of those electrical boxes. So all of this needs to be handled. It needs to be poly sealed. It needs to be corrected and sealed. It needs to be polyed. A shadow here. So I'm going to say, well, let's look up in there at the shadow and make sure, is it blocked? They've done a really good job of that. The T-ply's got to be sealed. It's just really difficult to air seal all around that to have it not have any air leaks at all. Now we're in the master bedroom, another barrel ceiling that's here. They've got a gasket under the beam. I like to see that. They've done that really well. But as we did in the other room, there's blocks all the way around the back of that half barrel that needs to be poly sealed. Just protecting the R value of the insulation, maintaining the R value without having air get into the cavity. Remember, air will move due to temperature differences, not that there's a draft or something's pulling on it. So air leaking through here, so polyseal and all of that, making sure that's done. Again, evidence of duct testing on this house. That hole really needs to be a lot bigger. But if any of you raiders are on the call, there's a hole right here, which is a telltale sign that the person that was doing the testing actually cheated the test by putting your probe here and testing from the same location, not running the pipe somewhere else. Is that acceptable? No, it's not. So you should not see a probe hole in that return. Blocked at the double wall here. Poly sealing the double walls there. Just following the gasket. This is now into the utility room. Verifying the gasketing here. Water piping for the laundry. They've left this as a T-wall where you can insulate behind it. So they did a really good job of doing that. And again, on the corners, tight corners, not leaving it just bowed out to where it can break when the sheetrock goes up, just tight corners. That's really good attention to detail. And then on this one, we're looking at that same house with the great room, but we're looking now at the other side of the room, looking at the fireplaces. There's a decking board here. It's dropped. I see polyseal around the transition. I also see fire caulking around the flue pipe, but there's a hole that's left here. It was not caught on the inspection. That again is where we're talking about. They polysealed around the front. It looks correct from where I'm standing, but you really put eyes on it and you start seeing that it's wide open to the attic. Fireplaces are notorious to leak. They're not going to really seal that fireplace against the stone or the rock or the brick or the sheetrock that's on the inside. So there's going to be a lot of air that can leak through there. So that attention to detail should be followed. Double wall in the back, making sure it's all there. Gasketing that's there. This niche was handled pretty well. And then this is the back side of the same one. So we're now on the other side of that wall. I spared you from having to walk around that, but he's called it out with blocking and sealing at the top, needing T-ply to be added here. There is T-ply. They've nailed it. They need to poly seal it. It's really hard to actually air seal around all those wires. They'll do the best to just poly seal and spray it there, but you're still going to get air leaking around those wires. And then checking the header. I always have a bad habit of doing that, but just this one is insulated, so it's done correctly. Vault ceilings dropping down, making sure the top of each of those corners are air sealed. Verifying the blocking is there and it's done correctly to be air sealed at that point. looking at the gasket, making sure it's got a backer behind it and it's actually aligned correctly, which it is. Poly sealing all the boxes, all the security, all the smoke boxes, fire alarms, everything that's there. Now we're off into the master, making sure the plumbing is done. The vault ceilings, that knee wall doesn't matter anymore because there's not anything sticking up into the conditioned space. T-wall, got areas for insulation back there. Right size header for load. It is insulated. The blocking here was close. It was pushed up a little too high for my likings. The backing was not really there for the gasket, but it was pretty close. All the plumbing penetrations have been sealed. Same thing with this. There's blocking that's been put here. It's a little too high. There's barely a lip there for the gasket to actually meet against. That's a shear wall with structural T-ply there. We'll see what happens there. It caused a little bit of an issue with the bathtub. Two stud corner. Now we'll just walk around into the bathroom area, the second bath. There's the plumbing wall. Now there's a bathtub that's there. And you already see they've spray painted the floor. So they actually pre-T-plied the back of the bathtub, but they did the length of the tub that's in the interior. The short run of the tub is against the exterior, needs a blocking underneath that tub. They insulated it. I stuck my hand down in there and you can actually feel and touch the tub. So there is not an interior air barrier. So that's what they're asking them to do. The problem is, how are they going to fix it? They've T-plied here, they've T-plied there. They're going to have to remove some of that to get to that point. It's just a little bit more difficult than it should have been pre-planned. But plumbing walls, making sure there's plumbing penetrations, all have been sealed. Gas line's been sealed. Electrical's been sealed. The blocking, again, pushed a little too high for my liking. Still kind of effective from what we're looking at. Checking out the bath fan, just making sure it goes all the way to the outside. They used a T-splitter for 2 different bath fans, so that was excellent. It's the best way to do it. Trying to cram 2 in one hole means the bath fans are going to fail to test as an airflow for Energy Star, and now code will not pass for 50 CFM. Polysealing all the seams of the T-ply, polysealing the corners, polysealing the seams against the base plate, against the top plate. I kind of zoomed in on this, but for Energy Star, the windows themselves have to be 1 pair of cat kings, 1 pair of jacks, minimal cripples, right size header for load. So that window is meeting Energy Star requirements. It is insulated as well, so that's done like it should have been. Again, looking at a short knee wall that's here. T-ply is done correctly. Air sealing's done correctly. The gasket's done correctly. Another attic stairs inside the house. So I make sure A, is it poly sealed around all of the door, and it is. So I tried to verify this door. I know it's an R10 door, but it was the little binding there. I didn't want to force it, so I just kind of left it there. But it is an insulated door. It is weather stripped because those doors come with gaskets. A little haphazardly on the cutting of T-ply, but it is poly sealed on the back. Making sure, again, these back knee walls, vault knee walls, are actually air sealed correctly, blocked at the top of all of these. I can't tell you how many times those have been missed. T-ply done correctly, gasket done correctly. Here we have a boxed header. I thought they were trying to do something a little different with a boxed header so they could insulate the header a little bit better, but then I realized they probably did that for load, was to have this big beam because they have a lot of load carrying on each side. I understand why they did it. However, we'll zoom in real close on this. The way it's stacked with wood, one piece of that could have been R3 board to break that thermal bridge. It's not. So this is a complete thermal bridge, which means it'll show up red hot with an IR camera at during the summer, and probably white or blue during the winter. It's just a lot of heat going to be transferred in and out of the building at that one point. Does it meet Energy Star? Maybe, I don't know. I'd have to read the requirements just to see. We've already saw that. Here's another one where we're actually looking at This is usually I see these on townhomes. This is a single story. I saw these stairs and thought, I'm not sure why they're doing that. This is not a two-story home. Again, knowing your scope of work, I knew it was a one-story, but walking in and seeing stairs kind of threw me for a loop. But it's because this goes up into the attic, and you'll see in a minute how that's done. But just real close to pay attention to, picture framing the exterior garage wall, excellent choice of detail. Poly sealing the big gaps instead of trying to crab insulation in it. Poly sealing between every single rung of the stairs. Absolutely needed. If it was conditioned floor above, you'll see in a minute this is kind of an overkill, but it was kind of a toss up on where they were putting the envelope. This is where they're trying to decide, is the garage wall the exterior envelope or is the stairs the exterior envelope? Do we include the stairs on the exterior envelope or do we not include the stairs? It was best to not include the stairs, but they kind of did both. They included it and they also took steps to not include it. So it looks like they could insulate all of that and do a perfect job. And they probably did that because the homeowner is probably going to condition that later. But now it's not a conditioned space, so it's out of the envelope. So they probably did that for future use. And I see why they probably did that. So just making sure it's picture framed around there. Again, in 2024 code, we've talked about it if you saw that webinar. They've now addressed any gaps 1 inch or less can be poly sealed and not have to have insulation. So they've done that here. They're already taking a good step, making sure the door is insulated or poly sealed around it. There's gasket around the door. All the electrical has been sealed around that where the electrical box is. Again, just a pet peeve of mine. You've got a water box here. It's not framed. So that door is never gasketed. It's just a metal door. So that is a complete hole inside that cavity to any electrical box. I know the electrical boxes are poly sealed. It's still going to breathe air. Sheetrock's cut short a ½ inch off the floor. It's going to pull air underneath it. It's just an air gap into that. It should just be blocked and sealed. Now we're looking at the stairs itself and identifying where is the envelope? Where does it start and where does it stop? First, it looks like it's on the garage wall, but then it also looks like it's on the interior. So in my opinion, they did this on the interior. So in the future, when they condition this second floor and build a bonus room, it's now part of the conditioned space. This door eventually should, when it goes for final inspection, will have a gasketed and a threshold door. If not, it should be called out and failed because that is the separation from conditioned to unconditioned space. But they've T-plied it. They T-plied it inside of there, but you can see it's directly to the outside or attic space. Following this, they T-plied the back of the stairs. They did a really good job. They did a good job of making sure this is another air barrier on the inside. They poly sealed all around the penetrations where the stair meets the interior. So they've moved the thermal envelope inside to this space here, but they also did the outside. So that's, in my opinion, why I think they're probably going to condition that second floor eventually. And then double wall here, T-plied correctly. We've already seen that block and seal at the top. Following the staircase all the way up, it's poly sealed, making sure the T-ply is poly sealed. They did a really, really good job with that. So that's done really well. But just big question mark as to what are they doing here? Where are they putting the envelope? How far is it going to go out? Where does it start? Where does it stop? Defining the envelope barrier. That's what an energy inspector should do, is find out where are they starting, where are they stopping. They could have not included the stairs and left all that open, and it would have been fine because they air sealed the interior wall or the garage wall. But they did it anyways, and they probably did it for future use to be done. So not a video with this, but just wanted to point out ceiling separations in floor over garage. With this, it is already insulated. But as you see, there's a support beam here. There's a small attic that's unconditioned attic that will not be insulated. So then there's a part of a floor that is insulated. And so they've actually put a gasket at the beam below and they followed the separation all the way around. So that's, you really need to have that done. Floors should be self-contained over ambient, over outside, over the garage. And then needs to be sealed in any separation from condition to unconditioned, which is what they did here at the gasket. And then top plate penetrations must be sealed. They did that against the wall. However, electrical boxes and light boxes on the ceiling should also be sealed, and I rarely ever see that done. I did not take a picture of this one, but it wasn't done at this one either. There was no sealing of those boxes. That's a in a energy world, that is a conditioned floor above, and what you're looking at is should be self-contained as a conditioned floor as a air barrier before it can get to the insulation. This is a little bit odd to look at, but it's just a most of the time these are little closets that push out over the outside over the front door. This creates a porch. So they created the porch, but instead of having an odd roofing detail, they actually made a room above it. This should be insulated at the bottom. This is it on the other side being inside the garage. You can see underneath it into the floor. This is a uninsulated garage attic that will never have insulation in it. So it needs to have a block or T-ply underneath this as well to seal that off. There won't be sheetrock on there because it's in the attic. So where the sheetrock would have been if it was in the over the garage and they had to sheetrock the garage, but since it's away from the ceiling, they're going to have to add another blocking below here. However, when I walked inside this house and looked at this upstairs, this was not part of the conditioned space. It's just a decorative window and a decorative room without access from homeowner. There was no opening for that. It was T-plied closed. So this is a fully unconditioned attic room, as you would say. So this didn't have to be insulated. They don't have to block and seal. But if this was a conditioned space, all that game changes. So all of it needs to be insulated, needs to be air sealed, should have a gasket around the underneath of this floor, should have blocking underneath it, should be insulated, pushed against the conditioned floor. So it should be self-contained. Plumbing walls, utility plumbing walls, always a raceway for air. This is a top plate built really high for the rooms adjacent to it, and then they block down and they pull down the ceiling. They try to block it all up. They don't want to cut so many. They don't want to, the piping was already here. They don't want to drill a hole around it. They don't have anything to nail to. They just leave it open. It really needs to be blocked. It can't just be left open. That's a pathway directly into the house, and we'll see evidence of how that can make it in just a second. But this is a 2x6 with a 2x4 sandwiched on top. The gap in between is not sealed. So again, shadows, you look up in the shadow and you can see gaps into the attic, which means all that needs to be sealed, and it's not. This is just another one from a backside of that, looking at the T-ply where it's got holes for penetrations that need to be sealed. Dead spaces, chases, duct chases, all need to be blocked and sealed at the attic level. Yeah, you could T-ply the front of this wall. You could make this dead space with T-ply, not having it open to that. However, that's going to diminish the R value of the ceiling, because when they blow attic insulation in, it's going to have to be tapered. If this was 2021, they would have to use damming here, but they're not. And so since they're not damming this, that insulation would just fall over. So they actually blocked it at the attic level. I always like to say, if this dead space wasn't here, this would be sheetrock. But since the dead space is there, you add blocking wherever sheetrock would have been. And then, of course, polysealing around ducts. They did a really good job of separating the ducts and then put blocking in between so they could poly it. When they have it too tight and all the ducts are crammed together, you can't seal between ductwork. It's almost impossible. And then with this, you've got a 10-foot plate dropped into a 9-foot plate with vaults. This is a different house, but they've now have to cut every single one of these blocks. But this is what I was talking about with the blocking. Without gasket there, you can now see clearly the blocks are in the right place for the gaskets to go against. On the other house, the blocks were pushed up inside that wall, no place for the gasket to rest to, still allowing air to move from the attic into the conditioned space. So all of that needs to be done, but this is always, a lot of times this is missed in real low-end custom or low-end production builders. They do it to look decorative, but then they don't worry about air sealing, and it's tough to block between it. I get it. This is kind of hard to see, but I'm standing in the kitchen on the left side of the picture. I'm standing in the kitchen. This is the vent pipe for the flue on the stove for the kitchen vent hood. This is, I don't know why they're putting T-ply here. It's not red. It's not structural. It can't really be used for shear wall, but they've T-plied it, which is, I guess that's fine. But if you look really closely, you see T-ply sticking way up into the attic, which looked odd to me. So I walked on the back side of that. What happened was the person cut the T-ply at the right height came across the back, but didn't want to cut around all the ceiling joists. So they just laid it on top of the ceiling joist in the lower ceiling and left the bottom of this wide open. So again, will air make it up into there? That's not what we're concerned about. What we're concerned about is detriment of the R value on the kitchen side from the air making it into there. With Energy Star, if this is an R38 or R49 blown attic, and there is R21 in all directions, they don't have to have an additional air barrier at that point. If this house is not Energy Star, which I don't believe that it is, code does not allow that, which means this needs to be fully encapsulated and it needs to be blocked and sealed at the bottom. They shouldn't really try to fill all that with polyseal because now you're diminishing the insulation at that one point. So framers doing this, just kind of being lazy, not wanting to cut around the T-ply, not really wanting to drop that in correctly. I know there's a lot of wiring there. There's a lot of plumbing, I understand, but it should be planned out to be done pre-utilities. But it wasn't. So that afterthought, and they're not really going to be able to fix it very well. This one, completely missing the point. This is a lower ceiling. If you're looking at the picture on the left, this is the same picture on the right, but from the other side of the room. You've got no top plate here. I understand it's truss framing, but they took the truss framing and they didn't add to it to create top plates. There's openings to the attic all the way down these walls. I don't know how this building would even pass a blower door. It's a very small home too, so it's probably not gonna, it'll be a really, really, really high ACH. So blocking should be here, right where we see this 2x4. There should be blocks in there creating another top plate to this wall, not just allowing it to go up inside the attic. This is just completely missing the point of what they're trying to do. Another truss framing here. These blocks on the right side that you see, these are here. Thankfully, they were done correctly. Most of the time we see those not there. The wall is built with a top plate really high in the attic so that the trusses can lay on it. I get it. I see why they do that. But then they don't recreate another band joist where it separates it from conditioned to unconditioned attic. And usually there's air that goes all the way down these walls. Here they've done it correctly. Even if the truss is set away from it a little bit, not a really big deal. But they should use a gasket. If they use a gasket, it'll be sealed. If they don't use a gasket, good luck at passing the blower door test. Probably won't happen. And then this one, I am really not sure how this works. I don't know how you get by without having a top plate. Whoops, sorry, a top plate against the top of this exterior door. I kind of with no words here, but missing top plate, no support for the sheetrock on that one corner. The wiring is actually shorter and comes into the conditioned space. When they go to sheetrock it, he's going to probably try to push it out of the way. I hope it doesn't disconnect somewhere. Also, what's questionable is if the top plate was here, what we're looking at is the front door. So the top of this wall in the attic is adjacent to a front porch, which means it doesn't need to be insulated, but they fully insulated it all the way to the top, which isn't necessary. And there's no separation from that to the conditioned space. So not a good idea. No T-ply on the inside, nothing stopping air from getting in there and diminishing the R13 that's in the wall. Not a really good design effect on the way they're doing it. Same thing with that. This is the same builder. No T-ply on the knee walls on the backside. It's truss framing again. Little niche there, plumbing that's coming out here. I understand they got a lot of things they have to cut around. There's a top plate here you can easily nail to, but there's not a top plate over here by the way they framed it. I mean, it kind of is there, but you have to bend the stuff around it and probably, I don't know, polyseal all of that. It's going to be a tough way to fix. It can be done, but poor planning on how they're doing it. And then, of course, looking at air sealing requirements on all ceiling penetrations. So if you think about it, the exterior outermost air barrier is the T-ply, the OSB, or the house wrap, or zip board. That's the most exterior air barrier. But when you get inside, unless it's a foamed house, the air barrier is the ceiling that you're looking at when you're standing in the room. If you look up and you see lights and bath fans and HVAC ducts, that's the air barrier. By code, they have to be air sealed. Polysealing around the electrical box, that's one. Two, air sealing around the hole through the penetration of the sheetrock. That's the second one. That needs to be done. It hasn't been done yet. A lot of times they call it poly stage 2 or stage 2 poly. It's done after sheetrock goes up. Someone comes in with caulking guns or poly seal, and they poly or caulk all of these. I don't think this builder is having anybody do that. They're just going to hope for the best. But ceiling penetrations, including all electrical boxes, ceiling fan pancake boxes, can lights, HVAC supply and return boots, gap around bath fan housings, low volt boxes for security and fire and smoke, CO detectors, AV boxes for media rooms, and then gaps around any vent pipes that are there should also have air sealing around it as well. So a lot of times they say, well, we'll go up in the attic and send somebody up there, turn all the lights on in the house once the light fixtures are there. Before attic insulation goes up, any daylight that you see, you need to seal it with caulking or poly seal. That's one really good way to do it. But that air, a lot of people miss this because they don't think it's part of the envelope. It's kind of like the garage wall. They don't see the garage wall as the ending of the envelope. Here in a blown attic insulation, this is the end of the envelope. This is where it starts and stops, and all of these need to be sealed. Really, if I was building a house, right at this stage, even right before texture. Texture was blown right before I got there today, but right before texture, take a guy in there with poly guns, caulking guns, any penetration that has been cut in the sheetrock has to get fixed, has to get sealed. And that includes what we see here. This is not code required. If everything's sealed at the top, that's code required. This is an interior wall on the other side of this wall because it's a bathroom wall, but I guarantee you nothing is perfect in construction. You've seen the defects we just looked at. This is a second line of defense for air stop. But now's the time to fix it before cabinets go in, before plumbing fixtures go in, before tile goes up. All of that this is the time to fix this. Around plumbing pipes, electrical boxes, under cabinet sinks, where the sinks are going to go. I can't tell you how many times I've opened those doors during a blower door, and it just is just a mountain of air coming out of those doors. It's the cabinets dropped. Now you can't get to the penetration because the cabinets have a backer on it. There's not really a way to seal it. If you seal it against the cabinet, now it's going to leak under the cabinet. You should do it before cabinets go up. And then around all the electrical boxes, around the plumbing shower head pipes, around the lines for the shower valve and the tub spout, all of that should be done. So a lot of times, again, just referred to as second stage poly, two-stage poly, final stage poly. But when air sealing details like this are not done, this is where the homeowner is going to feel the air. This is where the homeowner's complaints are going to come from is I feel a draft in my second bath. Well, this is why your bath and your second bath is staying colder on a tile floor, vinyl flooring, no carpet. It feels colder because the floor is colder because the cold air is falling as it comes out of those pipes around the wall. It's making those floors feel colder. I just went ahead and shot some of this real quick. I wasn't able to get video. There was security on site. They didn't really like me being there. I just told them I'd snap some quick pictures and leave. So I did. But townhouse common walls, the fire break on the common walls, they've done a really good job here with putting additional rock or glass pack. They've put caulking and not poly seal. So in my opinion, done excellent. They've got gasketing at the top. So at the attic level, it should be sealed only at the attic level. If it's a 3-story, then you do it right where it gets adjacent to the second floor. However, pay close attention to the front and back connecting points of all floors. A lot of times with townhouses, they'll offset them to make them not look like one big box. That offsetting creates openings at the front and back of all these townhouses. And that a lot of times will fail a blower door is those connections between units. So pay close attention to that. In my opinion, even if they just filled that full of poly seal to air seal it, it's better than trying to insulate it and have air come through it. Just a really bad area. But another big one with townhouses, subfloors over garage or over ambient over the outside, always a point of leakage. Can't tell you how many times they just have the floor joists butting out over a front porch and missing blocking altogether because they just think, well, it's going to be cornice board will be put on the outside. The fascia board will go against it. That's what we're concerned with. And it's also going to be insulated because it's the floor jutting out over that. It still needs to be air sealed. You have to have a band joist created over that. This one was done correctly. I didn't take pictures of that. But watch for newly created openings after air sealing has been performed. Here on the top left, you see polyseal's been done. They're all finished. It's buttoned up. And then someone comes in and cuts holes for vent piping and bath fans. So if this isn't noticed and fixed, that will probably fail blower door. Everything else they've done correctly, if they did correctly, still fail blower door. Decking and support beams. The one on the lower left-hand side, the bottom picture, this is the same house, just adjacent to the right, but you're looking at subflooring of the conditioned floor. You're looking at the beam that's holding the second floor, and then suddenly there's a massive gap between the 2x10 or 2x12, I can't remember what that was, and the 2x6 that's above that. That is going to suck air from a attic that's not going to be insulated because it's over the garage. So it's going to suck air into this floor and through the seams in between the floor. So all of that should be blocked. It should be self-contained like we saw on the other, gasketed underneath the beam, gasketed and polysealed on all edges. Should be a self-contained floor over the garage. Townhouse plumbing walls. This is the kind of the same thing we saw earlier on the other houses where they were butted together, but this one's not. It's left wide open. And as we can see, the gasket doesn't continue in the back. I don't know that the break in the firewall has been sealed as well. It was probably done after the fact. So that's probably a real big sign of air leakage. This opens up to the plumbing that's right there on that wall. Since it's interior, they're not air sealing the plumbing and they don't have to. But when you leave it opened at the top to the attic, that's where all the air is going to come from. I don't know how many times I can tell you that most of the time when I do townhouses and do blower door, they're probably not going to pass a blower door, and it's probably not ever going to pass a blower door by the way that they're designed and developed. And then lastly, under the wall on the water heater deck, these always need to have blocks and seals if they're on adjacent to the garage wall. As we talked about before, if this decking was not present, it would be sheetrocked. Since the decking has been built in front of the wall and they've already got that there before sheetrock, then they're not going to sheetrock that. Still needs to protect the insulation on the garage wall, which means you still need to have an air barrier on the garage side under the water heater deck to protect the R value of the insulation and to air seal underneath it. So that's listed on table 402.4.1.1, like we saw in the very beginning. That needs to be done. And then lastly, successful inspection. It's verified by the blower door in most cases. There's still cities not requiring blower door testing. Some of the states don't require blower door testing. But if it's tested for a blower door, you're verifying that the air barrier is somewhat sealed. Passing the test does not always mean that every hole was found and fixed. So getting a 3.99 on a requirement of 4 ACH means that you've passed the test, but that doesn't mean that homeowner complaint will stop. It doesn't mean that the air isn't going to make it inside the insulation. You should do the best that you can to try to get all air sealing done. Remember, as we said again and again and again, it's not all about maintaining, it's not all about air gaps and air making the building. It's also about maintaining the R value of the insulation, not just passing the test. Holes like this can be found with the infrared cameras. There's a lot of you guys that are on here that are real estate inspectors. You guys have IR cameras in your arsenal of tools. And so you'll see these holes just by going through and looking. You can see a point of insulation that looks a little different in color than the one adjacent to it, probably because there's a hole behind it. It's better to see with a blower door, but even if not, you can still see that there's holes there. Comfort issues can still arise even if the blower door is passed. So if you got a 3.99 out of 4, doesn't mean that the homeowner issues won't disappear. Doesn't mean that I fill a draft is going to go away. And then also the higher the ACH or air changes per hour, which is the test limit, means higher utility bills and increased chance of occupant discomfort and complaints. That's one reason why we have the energy code, not just to conserve energy, but also build houses a little tighter and have better indoor air quality, better comfort for the homeowners. If the homeowner is uncomfortable at all, they're going to change the thermostat, increasing energy consumption. That's why we do what we do. So pay no mind to the fact of misspelling of the green tag. This is an AI generated photo. they don't always get wording correct. So thanks again to everybody for joining us today. I appreciate you guys, and I appreciate the time that we're here. So please join us on the next webinar. It is Tuesday, February 27th at 10:30 a.m. It is Harnessing Earth's Power. It's an introduction to residential geothermal technology. So Will Lang, a director of utility engagement with Water Furnace, will join us and go through their technology, what they see, what's kind of separates them from the other geothermal heat pumps that are out there, and why geothermal is important to the future of lower energy consumption, more energy efficient buildings, and better comfort for the home. As always, here's my contact information. Please share this with anybody that can use our help. Please feel free to reach out to me at any time. I always welcome pictures and photos or short videos. If I get one from you, I will include it on a webinar, and I will give you credit for sending that to me. Again, thanks to everybody for joining us today. I appreciate your time. If you ever have any questions, feel free to reach out to me at any time, and we will see you on the next video. Thank you.